Hi, welcome to the final exam review examples, part B. And remember, just like the last review, we have A versions of each questions and B versions of each questions. In this first video, we're going to look at just the A versions. And then in the second video, we're going to look and see how to use the matching question to help answer the next question. Okay, so starting with 1A. If B, negative 2, 6, is rotated 90 degrees, what are the coordinates of B? So the first thing I want to do is figure out, well, what is the rule for rotation of 90 degrees? So what I'm going to do is I'm going to go to Schoology, and in my geometry course, I'm going to click on Resources. And then at the bottom of Resources, I can see that I have my geometry formula chart. And this way, I can find the rule to translate or to rotate 90 degrees. So my rotation rule for 90 degrees says xy rotates to the opposite of y, x. So xy rotates to the opposite of y, x. Let's write that down. xy rotates to the opposite of y, x. Okay, so then B is the point negative 2, 6, which means B prime is going to be the opposite of y. Right now, y is 6. The opposite of 6 is negative 6. And then x is negative 2, so it stays exactly as it is, negative 2. So B prime is going to be at negative 6, negative 2. All right, let's look at 2a. For 2a, given a radius of 5, find the length of arc GH. So to find the length of arc GH, let's see if that's on our formula chart. If not, we will talk through how to do that. Finding the length of an arc. So it looks like that is not going to be on this formula chart, okay? Which means we're going to definitely, when we are doing our test, if we need to remember how to do this, we are going to have to look back at this review, right? So what we need to do is we can look back at our notes. If we do look back at our notes, we're going to see that to find the arc length, we're going to do the measure of the arc over 360, because that tells us how much of the circle we're looking at, times the distance around the circle, which is circumference, 2 pi r. Okay, so the measure of the arc over 360 times 2 pi r. So then we're going to fill that in. Okay, so my length of GH, so that means that first I need the measure of arc GH. So arc GH is this arc right here because it's only 2 letters, so it's the shortest distance around. So I need to know how big just this little angle here is. Okay, I do have a diameter here because it goes through the center, so I know there's 180 degrees. I've used 20 and I've used 90. So far, 90 and 20 is 110. I know on one side of a line, there's 180 degrees. I've already used 110, so that leaves 70 left for here. So that 20, 90, and 70 make 180. So 70 degrees is the measure of the arc out of 360 times 2 pi. And then my radius it says is 5. Okay, I'm going to put this in the calculator just like this, but I'm not going to put the pi in. So I'm going to do 70 divided by 360 times 2 times 5. That gives me this fraction. So my length of arc GH, and I'm going to see if I can get that back to being a fraction, so that way I don't have to do the rounding and can get an exact answer. So remember, for fraction, I hit the math button, and I'm going to choose fraction, enter, and then enter again, and it says 35 over 18. Remember, we didn't put that pi in the calculator, so pi still needs to go next to that fraction. So 35/18 times pi is my length of GH. That's the exact answer. The approximate answer, I'm going to take this answer and say times, so take that previous answer times pi. And when I do that, I get an approximate answer. I'm going to round to 3 places, 108, and then that 6 says to round it up. So 6.109. I don't have units here, so I'm going to say units. This is my approximate answer, and this is my exact answer. Both are correct. Okay, let's look at 3A. Chords XY and chords WV are equidistant from the center, and I can see that because it's marked in the figure for me. I have my tick mark here and here. If XY is 2x plus 30, so this one here, XY is 2x plus 30, and VW is 5x minus 12, VW here is 5x minus 12, write an equation to allow you to find x. Okay, so we had a theorem in our notes that said if chords are equidistant from the center, then the chords are equal. So that means these chords, XY, is going to be equal to VW. XY is 2x plus 30, so just substitute that in. That's going to be equal to VW, which is 5x minus 12. Okay, if I wanted to solve this, I would first want to get my x's together. I like to move the small one because that way I can keep my x's positive. All the positivity we can get right now. 30 equals 3x minus 12. I'm going to add 12 to both sides. When I do that, 30 plus 12 is 42 equals 3x. Divide both sides by 3, division property of equality. And 42 divided by 3 is 14. So x equals 14. Now, did I answer my question? Because sometimes they ask how long the chord is, right? So x is 14. And my question, it's not really a question. It just says to write an equation. Ooh, write an equation. I was done here. It doesn't hurt to plug it in though, right? And then you could, if you wanted to check your answer, you could plug in the 14 here and here, and you should get 2 equal chords, okay? But I just needed to write the equation to allow me to find x, okay? All right, let's look at 4A. 4A, find the measure of angle ABC. So for this one, the measure of angle ABC, I can see that my angle is on the edge of the circle. If I look at my formula chart, when I have my intersections on the circle, this angle in here, F, equals 1/2 the arc G. So the angle equals 1/2 the arc. The angle is 1/2 the arc. So when I come back here, the angle is 1/2 the arc. Okay? The angle is what I'm trying to find, the measure of angle ABC. I need to know how big is this arc right here. Okay? I know a whole circle has 360 degrees, and I've already used 105 for this piece, and I've used 95 for this piece, so I need to know what's left for the arc I'm looking for. So I'm going to add together the 105 plus the 95. And when I do that, that's 10. That's 10. So 200 is how many degrees I've used that I'm not interested in out of 360. So 360 minus 200 is 160. So that is this arc right here is 160. So my measure of angle ABC is 1/2 of 160. 1/2 of 160 is 80. So that angle is 80 degrees. The arc is 160. The angle is 80. The angle is half the arc. Okay, let's go look at 5A. All right, this time my angle is inside my figure. So when I look for an angle inside, this one kind of can be deceiving because it kind of looks similar to this picture, except I'm extending on the other one. If I keep looking, angle inside, look at this one. I've got an arc, I've got an angle, I've got an arc. I'm looking at intersections inside a circle. D equals 1/2 C plus E. So D is the angle, and it equals 1/2 C, the arc, plus E, the other arc. So my angle is 1/2 the sum of the two arcs. My angle is 1/2 the sum of the two arcs. The angle is 1/2 the sum of the two arcs. Okay, so this angle, X, which is the same on both sides, is 1/2. If I come out of X, I hit 110 on one side, plus 130 on the other side. So X is going to equal 1/2 times 110 plus 130. When I do that, I get 120 degrees. Okay, and that's going to be for the angle that's in between directly, that if I draw a line from one arc to the other, it's the angle that that line would go between. 120 degrees. Okay, let's look at 6A. 6A, find the measure of arc GH. Well, I believe we've already done that because we found the length of arc GH. And in order to find the length of arc GH, we had to find the measure. But we'll review it just so that we can make sure we have a good understanding of how to find this arc. Remember, if you have a diameter, there's 180 degrees on one side of a diameter. I've used 20, I've used 90, so I need to know what's left for this one. So 20 plus 90 is 110 out of 180 degrees, leaves me with 70 degrees. So the measure of arc GH is 70 degrees. That's different from its length, right? We use the measure to find the length. Okay, let's look at 7A. 7A, PQ, QR, RS, and SP are tangent to circle X. Find RS. So remember, when you have tangent segments, each little piece here that goes to the point of tangency are going to be equal. So if PQ is 8, then Q to this intersection is also 8. If R to the point of tangency is 6, then R to the other point of tangency is also 6. If S to the point of tangency is 7, then S to the other point of tangency is also 7. And if P to the point of tangency is 1, then P to the point of tangency is 1. So now my question is to find RS. So from R to S, how long is that? Well, I have to travel 7 and I have to travel 6. So 7 plus 6. RS has a distance of, from R to S, is 7 plus 6. That is 13. What are these? These are inches. RS equals 13 inches. Okay, let's look at 8A. So 8A, when I look at this one and I look back at my formula chart, I'm going to notice that on these, I'm given segment lengths. I'm not working with angles. I'm working with distances. So that's a little bit different than the last time we looked at a picture similar to this. So I'm not looking at angles. I'm not looking at degree measures. I'm looking at distances. So it's going to be more like this one, where it says TV equals W times U. So T times V equals W times U. So each little piece of the segment multiplied together equals each little piece of the segment multiplied together. So my 3 times my X is going to be equal to the 7 times the 5. So 3 times x is 3x. 7 times 5 is 35. To solve this, I'm going to divide both sides by 3. When I do that, if I do 35 divided by 3, I get a decimal. If I want it as a fraction, it stays 35 divided by 3. So that doesn't reduce 35 thirds if I want an exact answer. If I round up to 3 places, it's going to be the one right above it, the 11.6 repeating. So I'm going to say 11.667 when I round correctly, and we don't have the units here, so I'm just going to say units. Okay, let's look at 9a. Find the center and the radius of a circle whose equation is x plus 15 squared plus y minus 20 squared equals 100. Let's see if this is on our formula chart. So equations of circles, here, equation of a circle. X minus h squared plus y minus k squared equals r squared. So what we remember is that when you put the center point in, the x and the y from the center, it's going to change the sign, what it looks like the sign is when it's inside the equation. Okay, so that means when I'm looking at the center, my center really came from a negative 15. So that way when I put minus negative 15, it became a plus. And then my y really came from a positive 20. So when I put it in there, I had y minus that positive 20. My radius, in the equation, the radius gets squared. So to find my radius, I have to unsquare it. My radius is going to be the square root of 100, which is 10. And we don't know the units, so I'm just going to say units. So I have my center, and I have my radius. Okay, let's look at number 10. Find the area of the circle. So area of a circle is pi r squared, and if we forget that, it's on our formula chart. Area of a circle, pi r squared. Area equals pi r squared. So my area equals pi times my radius squared. If all the way across is 32, then just halfway across is 16. 16 squared is 256, so my area equals 256 pi inches. That's my exact answer. Multiply that by pi, and that will give me my approximate answer, which I'm going to round to 3 places. I'm not sure what the test will ask me to round to. 804.248 inches. Oh, and their area, so inches squared. You have your exact answer and your approximate answer. Okay, let's look at 11a, the last one for this practice review. Okay, find the area of a regular hexagon with side length of 10 centimeters and an apothem of 8.66 centimeters. So if we don't remember a regular hexagon, we need to go and figure out what the formula is for a regular hexagon. So on my formula chart, we don't have a regular hexagon, but we have a regular polygon. And it says A, capital A equals 1/2 a little a, and P. And it tells me that the capital P is the perimeter of the polygon. And then A is this distance here in the center to the side. So my area, according to my formula chart, is 1/2 little a, capital P. And the little a is this distance here. So I know that is my 8.66. Area equals 1/2 8.66. And then P was perimeter. So it's going to be 10, 20, 30, 40, 50, 60 for my perimeter, right? Or we could do 10 times 6. 60 is my perimeter. So my area then is 1/2 times 8.66 times 60. 259.8. My units are centimeters squared because it's area. 8.66 centimeters times 60 centimeters. Centimeters times centimeters is centimeters squared. Okay? All right, so in the next video, what we're going to do is we're going to go through these same problems, but the B versions, and see how we can use our notes on the previous examples to help us on the second ones. All right, thanks for watching, and I'll see you in the next video.